Okay, selected problems from the review. This would be Mr. Wolf's picks. This is my picks, not based on what I think is on the test, but just kind of hitting one from each section. So take that for what it's worth. All right, number one. State the domain and range. Then say if it's a function. If it is a function, tell me if it's one-to-one. So a little bit of everything here. Domain, that's the x values. Be careful if you're giving a list of x values. This happened on the quiz. I didn't take off for it. But if you're giving a list of specific x values, you're supposed to use the squiggly brackets and list all the values. So 100, 200.
What if it's repeated? 300.
If it's repeated, you don't have to list it again. If you do, it's not wrong. It's just not necessary. On the quiz, a few people, I think they were thinking like interval notation, so they put something like 100 to 300. But that means, that's not right. That means everything from 100 to 300 is part of the domain. The only things in the domain are 100, 200, 300. So not this. That would be a whole lot more values than we have. So for these type functions, you're only going to list the x values and list the y values for the range. 50, 100, 150. All right, you tell me, is that a function?
Yep.
Yep. Why? Okay, there's no repeating x values. Be careful if you say that. What if I put that in there? Is it still a function?
Nope. Yes. Wait.
Right, because it goes to the same point. So be careful if all you do is say, oh, look, there's repeating x values. Well, you have to do more than that. So repeating x values is kind of the shorthand of what you're looking for, but the better answer would be each input goes to one output.
Are you using a process if we don't write it like this?
If you don't write it like this,
Yeah, like with the brackets.
if you list the points, you'll be okay. The trouble is if there's only 2 points and you list them with a parentheses, then that means you're trying to tell me all the points, and that would not be right. So yes, I'm going to take off if it's not brackets, because I won't be able to tell what you mean. So function, yes. Each input goes to one output. A couple people on the quiz, and I accepted this, they put, you know what you're going to get. They were thinking the vending machine example. Like if you push the 300 button, I know I'm getting 150. Is this one-to-one? Yep. Because I can go backwards. I know what button I push, right? It's the backwards question. If I'm standing there with that 100, I know that came from 200. You can go backwards. All right, 2, 3, 4, all kind of the same thing. So we can skip over those, I guess. But we could take questions as we go. Just looking at 2, 3, 4. Anything on those?
2 would not be a function.
Correct. 2 is not a function, because when you push the 3 button, you're getting a 1 and a 5. Right? That's the bonus drink from the vending machine, which is nice, but that's not a function. Mm-hmm. Good one. Thank you. Kinley, good out. Congrats.
You still do the domain and range, just the same.
You would, although, yeah, you would.
Okay.
Not much there. That's a good one to list on the range, because, again, if you put 1 and 5 in parentheses, you're telling me it's everything from 1 to 5. If you put it in brackets, you're telling me it's everything from 1 to 5. If you just mean the points or the values 1 and 5, then it needs to be in the squiggly bracket things. I don't know what those things are called other than squiggly bracket things.
Would the domain and range on number 4 just be the farthest points?
So the domain for number 4, so that does cover a span of x values. It is the farthest points. That's the one we'll write down. So that looks like does that go 0 to 10? That looks like it goes past 10. I don't like these pictures. I think we're going to say it goes to 10. Although I don't like these pictures. Does that go to 10 or does that go to 11? I don't know. Or even 12. I think 11. Each tick mark is worth 2, so I'm going to go 11. So let's go 0 to 11. I want to include 0 and 11, so I put brackets. And that format, that notation means all the values from 0 through 11. It covers everything from 0 to 11. Range, same type thing. We'll go from -2 up to another unclear picture. I date 9. Again, we'll make sure your test pictures are better. And part of the reason I think 9, that way the domain and range are both 11, a span of 11, which would make that thing a circle. So I'll go -2 to 9. Oh, while we're here, is that a function?
No.
No. Which sort of means the one-to-one question doesn't matter. Because it's not a function, it's certainly not a one-to-one function. So you could say no, or you could just say that doesn't even apply anymore. Number 5. Graph each function, or graph each relation or equation, and determine the domain and range. So 2, -3, 2, 4, 2, -1. What's the domain for this one? Kind of a weird one. 2, just 2. And it's a list of values, so we'll do the squiggly brackets. The range, again, don't tell me the range is from -3 through 4, because that's not true. It doesn't cover everything from -3 to 4. It only hits -3, -1, and 4. The order of these values doesn't matter. I put them on bottom to top because I was looking at the graph. If you wanted to just list them from the points, your order might be different, but it would be the same set of points. That'd be okay. And then same questions. Is that a function?
Yes.
Why no?
Because it's the vertical line test.
Yeah, vertical line test is a good answer, right? That definitely fails the vertical line test. The only vertical line that you could draw crosses through 3 points, so that's not a function. The vending machine would be you push the 2 button and you get 3 different answers. It's like, that doesn't work, which means it's not one-to-one because that doesn't even apply. That's the one from that section I wanted to work. I guess we should comment on x equals -2. What kind of line is that? Is that the up and down line or the left and right line? I want all the points where x is -2. So I go to x equals -2, and I want all the points where x is -2. So that's an up and down line. Is it a function? Definitely not. Right, 9 through 14, function notation. So g of 4, just be careful, make sure you plug 4 in the right spot. G, meaning let's grab the g function, which is 2 minus the input squared. So whatever our input is, goes in on the other side, right there. So 2 minus 16 is -14. F of d means make sure you grab the f function, which is 2 times the input minus 1. This one maybe feels weird because our input's not a number, but it still works the same way. Whatever's in parentheses goes in on the other side, so 2d minus 1.
Where's the square?
Be careful, this one's the f function, There is no square on the f function. Is that what you're looking at? This one? G, however, is 2 minus input squared.
Yeah, I guess so.
Before you turn the page, really throw some people off here. What is f of pink triangle? If a pink triangle is my input.
2 pink triangle minus 1.
Perfect. Doesn't matter what's in there. Usually it's a number. That's what we like. Otherwise, weird stuff. But hey, if it's a pink triangle, it's a pink triangle. 2 pink triangle minus 1. 2D minus 1. Whatever's in parentheses goes in on the other side. I think the other 4, pretty easy. Just, again, be careful. Make sure you use F or G, depending on what's called for. That's a silly mistake that people make, because they'll use the F function for all of them or mess up and use the wrong function. Hey, speaking of pink triangles, number 15. F of x, but I want f of x minus 2. So that means in place of x, I have to put x minus 2. So input squared minus 4 times the inputs plus 1. So this one's kind of a pain because there's a lot of work to do. X minus 2 is my input. And then now it's just algebra cleaning this up. Let's see, x minus 2 squared is definitely not x squared minus 4 or x squared plus 4, right? Because we have to FOIL that. And then distribute the negative 4. Then?
I don't understand. So when you multiply usually when you like square a negative number, wouldn't it make a positive? So why is this case different?
So I'm not squaring a negative number, I'm squaring this x minus 2 thing. X times x is x squared. The O and the I of FOIL are both negative 2x, and then negative 2 times negative 2 is 4, positive 4. You're right, if you square a negative number, you get a positive number. But I don't know what x minus 2 is. I guess I could phrase it this way. X squared minus 4x plus 4 is always going to be positive because it came from squaring something. Like, it doesn't mean that every single term is positive. I think that's what you're trying to say. But it doesn't mean that. Right. Now I'm just collecting like terms, so x squared, and then minus 4x would be minus 8x, and plus 4 plus 8 plus 1 is plus 13. And then we go look at our answer choices and hope that it's there. And it is, so feeling pretty good about that one. Question? Kinley? Sure? Okay. Let's look at 17. Similar question, but even more complicated, because now I need to find all of this. And I can't find all of that until I find each of the pieces. So I need to first find f of a plus h. So I look at the f function. It's the input squared plus the input. And I need to find f of a. That one won't be as bad. And once I find each of those pieces, then I'll plug it into that. But let's slow down for a minute. I want you to find both of those pieces, and then we'll see if we can put it together. I mean, this is, I don't know how to say it. This is Algebra 1. You have to be able to factor. Like, you have to be able to factor. I mean, we can go back and...
I do kind of understand it, it's just I don't fully understand it.
So how could I factor 3a squared plus a? What can I take out of both of those? An a, and what does that leave behind? And what leaves behind is I have to be able to multiply it back to get to 3a squared plus a. 3a plus 1. Because I took an a from each of those.
So you took the A from all the sides.
So I took an a from each of the terms.
But what about the bottom H?
Well, the bottom h was there. That means I can cancel. Now I have an h out front.
So you took the H from the bottom H.
I did not take the h from the bottom h. I factored the top. Because this is the same thing as this. Those are exactly the same thing. They're written different, but those are exactly the same thing. Once I factor that h out from the top, then I'm eligible to cancel those factors. Yeah, I can't cancel those h's with the terms.
I have a question. How did you get rid of h squared?
Right here?
Yeah, right there.
Because h, if I factor off an h from h squared, that leaves h. Another way to say it is if I distributed this back, h times h would be h squared. Same thing with this one. A times a would be 3a squared. Corinna, did you have a question?
Yeah, I was just, but I guess the factor thing is not terms. I was saying, how are we able to take away the h if it's attached to 2a?
These are all multiplied to AH, like 2 times A times H. So I can sort of unmultiply that H and put it out front.
Okay.
What can I factor off of that? We'll go back up to a Y. And what does that leave in parentheses? 7x plus y. Because if I distributed the y, I'd get back to 7xy plus y squared. Let's do one more. Let's see. 18x squared plus 6x. What could I factor out of that? What else could I factor out? X isn't wrong, but I could factor out a 6. And then what would need to be in parentheses? 3x plus 1. You have to have a 1 there so that if you distributed, you'd get that 6x back.
So there's like plus like 12 on the end of that. You can't factor it all, right?
So if there was a plus 12 on the end of that, that's a good question. 18x squared plus 6x plus 12, something like that. You could take a 6 out. Couldn't take any x's out because that doesn't have any x's to give, but you could definitely take a 6 out. Like that. Okay, Algebra 1 review over. Let's go back to Algebra 2. Let's hold off on 18. We might do that one tomorrow, we might not. Let's hold off on that one. That one's a tricky one. All right, the next page is graphing absolute value. Man, we've done a bunch of those. I feel like you're pretty good at those. So, enough of me talking. Why don't you try number 22? All right, most of your 22s look good, so let's do 22 real quick. Right 4, down 3. Start there. What's that 1/2 do to the graph?
Vertical compression.
Vertical compression is the fancy way to say it.
Horizontal stretch.
I shouldn't even write it down because not officially the slope, but that's what you mean. Yeah, it has a slope of 1/2. This one did ask for domain and range. Let's pick on some people. Let Michael off the hook. He's explaining something to someone. Scarlett, how about the domain? Oh, Michael's back with us. We'll let him do range then. Scarlett, how about the domain? Well, sort of, but we don't say infinity to infinity. How far left does it go? I need this to be more specific. Both of those are like all the way out here to the right. I need something that tells me to go all the way out to the left. Negative infinity. Michael, how about the range, bottom to top? So range is the y value, so I start at the bottom and work my way up. What's the... There you go. -3 up to infinity. And we want to include -3. Let's look at 21. Most of you realize you got to take that 2 out of there, but you have to factor it out of both numbers. This matches what we were doing a minute ago. If I take the 2 off of both of them, if I divide both of the pieces by 2, what's left on the inside? X minus 1. So then I've got right 1, up 3, stretch by 2. So the slope, asterisk, sort of, the slope is 2, the steepness is 2. Okay, we had a little bit of everything. I'm going to stop the video here, but you still got 15 minutes or so to keep working, and then tomorrow I'll answer whatever questions you have. There's also one final review page at the back, but read the directions. This will go really quick, because all you're doing is describing the transformations. So I guess let's do a couple of those together so you know what I'm looking for here. So, Aiden, how would you describe the transformation of that first one? X plus 6 squared. What's the plus 6 do to the graph? Left 6. So that's all this is asking. You're not graphing, you're not finding domain and range, you're just telling me what has changed. So, Ocean, what's one of the changes? We'll even get 2 people on this one. Down 4. And Kinley, what's that 3 doing out front? What's that do to the graph?
Vertical track.
Yep. So I think that's a pretty easy set of questions there to answer, just to keep you fresh on the transformation stuff. Okay, again, you've got 15 minutes or so to work, and then tomorrow I'll answer whatever further questions you have from the review.